implicit function. So here, when do we have implicit function? When we have s and y as one term in any function of s. For example, if you are given y, or let's say if you are given 2sy raised to power 3 plus 4s plus 8sy raised to power, let's say 2 is equal to 1 or 0. So this is implicit function. Why is it implicit function? S and y is now one term. But normally, we usually have y is function of s. We usually have y is function of s. But now, we have s and y as one term. Then how do you now solve this? As means that you are asked to find the y over the s. You will write solution. You will write solution. So the formula is this. You write 2sy raised to power 3 plus 4s plus 8sy raised to power 2 is 0. So you differentiate it term by term with respect to s. So differentiating term by term with respect to s. So how do you differentiate? So if you want to differentiate this, let me explain. As means that you have something like this, you want to differentiate a, b. Let's say with respect to s. This will give you a, you differentiate b with respect to s, then plus b, you differentiate a with respect to s. So this is the method you are going to use to differentiate these two. So if you come here now, you want to differentiate this, we are going to now assume that these two, s is constant. So you are going to have 2s. You differentiate y raised to power 3 with respect to s. Then how do you differentiate y with respect to s? If you have y, if you want to differentiate it, the answer will be the y over the s. But if you have y raised to power, let's say 4, if you differentiate, what will be the answer? You will just assume that this is s. So if you differentiate this as if it is s, it's going to give you 4 times 1 will be 4. 4 minus 1 will be 3. Then after everything, you now say the y over the s. So you're going to now use this to differentiate this. So if you come now, you keep these two s constant. So you now differentiate this. It's going to now give us, this time this is what? 3y raised to power 2. Then what again? You now put the y over the s. Then after that, you now say plus, you keep this y raised to power 3 constant. You now have y raised to power 3. Then you have to now differentiate 2s. So when you differentiate 2s with respect to s, you have what? 2. You have to. If you differentiate 2s with respect to s, that is, if y is 2s, how do you differentiate the y over the s? We now give you 1 is here now. 1 times 2 is 2. 1 minus 1 is 0. And then anything raised to power 0 is 1. And the 2 times 1 is 2. So that's how we got this 2. So I'm through with this. Remember, we are differentiating term by term. Then if you differentiate 4s with respect to s, the answer will be 4. Plus, here now, you also apply that method. So if you differentiate this, it's going to give you 8s. You now differentiate y raised to power 2, it's going to give you 2y dy over the s. Then plus, you keep this one constant, it will give you y raised to power 2. If you differentiate 8s, it's going to give you what? 8. So it's going to be equal to 0 because if you differentiate any constant, it is 0. So we can now open this bracket. If you open this bracket, you have 2 times 3 is 6 s y raised to power 2 dy over the s. Then plus this time this is what? 2y raised to power 3 plus 4 plus you open this bracket, it's going to give you 8 times this is what? 16 s y dy over the s. What again? What again? Plus 8y squared will give you 0. So the next step will be collect those terms that have dy over the s. So you say collecting terms of dy over the s. So you collect the terms that have, or you make it a sort of formula. You can say collecting like terms if you like. Collecting like terms. So all the terms that have dy over the s will be this side. Will be in the left hand side. While all the terms without dy over the s will be at the right hand side. So this one has dy over the s. So we're going to have 6s y raised to power 2 dy over the s plus 16 sy dy over the s will now be equal to, this one will now move over to this side. This one will now move over to this side. So it's going to give you minus 2y raised to power 3. 4 will move over to give you minus 4. This 8y raised to power 2 will move over. It will give you minus 8y raised to power 2. So the next step will be you collect like this. You now you factorize. You bring out this dy over the s because it is common between these two. So you factorize. So you write dy over the s, you open bracket, the whole of this divided by this, it will give you 6s y raised to power 2 plus the whole of this divided by this, it will give you 16 sy will now be equal to minus 2y raised to power 3 minus 8y raised to power 2 minus 4. So what the next step will be, you divide both sides by the coefficient of dy over the s. You divide by this one. So when you divide by this, it's going to give you dy over the s will now be, you write the whole of this. When you write the whole of this, it's going to give you 2y raised to power 3 minus 8y raised to power 2 minus 4 all over 6sy raised to power 2 plus 16sy, and that becomes the final answer.